Hello. Today, I will talk about learning how to code in 2021. However, this content should remain relevant in the future as well. So, what makes 2021 different? Well, for many years, there's already existed a buildup of changes in society with social media and other technologies. The first reason is that too much hype has been created. This isn't exclusive to the programming industry, but it's very prevalent. There's too much focus on misconceptions of what coding really is, what the day-to-day work is, and too much focus on high salaries and financial comfortability. There's also too much pressure. Many people code without really even enjoying it. And this is partly due to high pressure of doing something innovative, keeping up with career competition, or believing that everybody will need to code in the future, which is pretty far from the truth. The hardest part, though, is that the amount of noise in software is extreme. There's too much noise. There's too many tutorials, there's too many courses, too many forums, too many opinion pieces, and too many advertisements. As a matter of fact, if you search this video title up, you'd probably get hundreds of results. And I'm contributing to this noise myself. And I'm not saying people shouldn't upload tutorials or blogs at all, and they definitely should if they want to. But the point is, it's really hard to find the important signal in all of the noise, and this is especially true in 2021. So if you want a 5-second answer to this question without watching the whole video, here it is. Just code. A lot. And if you're still not good, code even more. But jokes aside, at the end of the day, like anything else, you need to actually do the action you want to become better at. Endless book reading will not make you a good coder. And inspired partly by George Hotz, instead of pointing you to some links of where to learn various programming languages and tools, I'll instead provide you with a framework of how to approach programming and problem solving. And hopefully, this will provide you with an overarching attack plan. So first, let's ask, what is a program anyways? People jump into coding without really internalizing this question. In the simplest terms, a program consists of three things: an input, computation, and an output. The input can vary from natural sensor data, user input, and so on. The computation then completes some sort of logic, extraction, or manipulation on that input, getting you to the final output. The output could be a numeric value, a data structure, or even a record being successfully created in a database with a return code. Next, we need to understand what a computer is. In simplest terms, a computer consists of many parts, but two important parts: the processor and RAM. The processor consists of a stream of instructions which handles the execution of instructions that make up a program. RAM, on the other hand, consists of instructions plus data. RAM gives your programs a place to access and store data short term. It's not a bad idea at all to learn about the underlying architecture in more detail. But if anything, it's important to at least be aware of how program execution takes place. And I feel like many people skip these parts when learning how to code. So, since most people that learn to code do it to eventually become employed programmers, I think it's really important to understand what the job is actually like. And this definitely isn't mentioned enough in high school or universities. So what does a software engineer actually do? Well, to start, they rarely write algorithms. In the real world, it'd be counterproductive to write algorithms from scratch all of the time, and it's often not even necessary for most problems. So to recap, it's just not too often that you'd actually use your algorithm knowledge. Next point, most software engineers are translators. This is because at the end of the day, if you're working for a business, the business won't care about nursing your coding skills or getting you to write the most optimal code. And rightfully so, because it usually doesn't matter. Companies began to use computers and programs as a way to automate and convenience their customers. So what's important is that the service or product is delivered, not that the code is there. And to some extent, the code is just a means to an end. This is why many engineers are very good at translating business requirements to code, but not necessarily great coders. This doesn't mean that great engineering culture and code standards don't exist, but most engineering in companies deals with business requirements being translated to code, instead of nature being translated to code. So trailing off that last point, let's talk about the most used application type, the CRUD app. CRUD stands for 4 operations: create, read, update, delete. Let's use an example of a hotel booking web application. In simple terms, I'll want guests to be able to book their stays, so creation of bookings will be needed. Maybe they'll also need a guest account to store their personal info. A CRUD application can be broken down into 3 components. the front end, or view, the business logic, or controller, and the database, or model. The view is in charge of providing an interface to users of the application so they can interact and complete actions within the system. The controller is in charge of taking in that user action, validating it if needed, and computing the necessary business logic, along with the request or update to the model. The model will then supply the requested information or complete a change to the controller, and from there the controller updates the view so that the users, whether it be a guest or employee, can see the modified information based on that previous action. So in general, you can see this creates a beautiful yet very simple framework to approach the creation of most applications. And in most businesses, these CRUD apps are the most common. So what's really left? Well, there's two important things that you need to remember when learning how to code. To be a great programmer, you need to learn meta skills, and you need to learn from nature. Meta skills are defined as higher order skills that enable and empower other skills to happen. Once you have overarching knowledge, learning many things becomes trivial and much easier. Focusing on nature is how you learn most of these meta skills. And it doesn't rely on trending tools or surface level usage, and it's simply a truth of the world we live in. The final important thing is to always focus on problems new to you. Notice the to you part. This doesn't mean everybody should be in cutting edge creation of products or research, but you should always be pushing yourself out of your comfort zone to gain knowledge. Not just because that knowledge will be directly useful to you, but if you pick the right things, there's a high chance the new knowledge you gain could fill in knowledge gaps for things you already thought you knew. So let's take a look at some things you shouldn't do. Do not focus on tooling, and do not engross yourself in surface level objects. This doesn't mean you shouldn't learn new frameworks or tools at all. You definitely need to. But you have to remember that the tools are something that can come and go, but the underlying concepts usually stay the same. So if your skills are based entirely on a tool existing, without understanding the underlying truths, chances are you're at high risk of losing your value in that field. So do not focus on tutorials and courses as well. While they're useful for gaining initial broad knowledge, you should try to maximize your time spent learning with action. Aim for 80% of learning with action, and if you're self-taught, definitely don't worry about completing more tutorials and courses. But again, don't get stuck into tutorial treadmill. Learning by doing will always prove more effective no matter what path you take. Finally, repetition is a very useful method to learning things. But once you become comfortable and well-versed in a language or topic, there's no need to continue drilling the same repeated problems. Chances are you'll excel more by using that knowledge to learn something new, even if it's just a small modification to what you already know. George mentioned in his video that at the end of the day, even the best engineers will eventually lose their jobs to AI. So don't stress yourself out too much. And if there's one thing you need to remember, it's to be able to tell stories. You should never forget that all software products and services serve a purpose that was manifested due to somebody's vision of bettering how we live. Coding is just a way to get there at the moment. But in the future, coding will be replaced by something different. So, I'll leave you with this quote to keep in mind while you're coding away. In the last analysis, magic, religion, and science are nothing but theories of thought, and as science has supplanted its predecessors, so it may hereafter be itself superseded by some more perfect hypothesis, perhaps by some totally different way of looking at the phenomena, of registering the shadows on the screen, of which we in this generation can form no idea. Sir James Fraser. Thank you for watching. Please like the video, subscribe for more, and I'll see you next time.